Good afternoon, everyone, and today's lecture is immunosuppressant drugs. The immune system is protecting our body against the foreign microorganisms, but sometimes there are cases when the immune system is damaging more than it will help the body. For example, in case of the organ transplantation, there is a rejection of the uh, transplant, and uh, the because of the progress in the medicine, nowadays the transplantation is commonly seen, and even here in Kazan we have a hospital that can uh, make transplantation for the kidney at least, and there are many other hospitals that can transplant bone marrow and heart, and other organs that uh, can be damaged irreversibly. And because of that, there is a revolution in the pharmacology of the immunosuppressive drugs, and that uh, makes the transplantation more safe and reliable. Um, the old drugs were non-selective and lead to the many adverse effects. However, the new drugs are more effective, uh, and the commonly seen the reason for the therapy is to change the lymphocyte function, or change the antibodies against immune proteins, and sometimes combination of the immunosuppressant can be used to decrease the toxicity because they are still have adverse effects, and uh, usually the several drugs are combined in the modern immunosuppressive therapy. Before we start the uh, discussing the drugs, let's revise the immunology and the type of the immune system we have in our body. So we have a innate and adaptive immune systems. So innate immune systems is a non-specific, and response is usually fast, and the cells that are responsible for these immune systems include macrophages, dendritic cells, and monocytes. So macrophages will eventually uh, become mast cells when they transfer to the tissues, and then also granulocytes, including eosinophils and neutrophils and basophils, are also responsible for the innate immune system. The opposite is adaptive immune system that is a more specific and more effective, but is somewhat slow to respond because the usually up to 2 weeks are required to produce the antibodies, enough antibodies for this uh, immune system. So sometimes this immune system is called a humoral, because it requires beta cells to produce antibodies, and the cellular response is with the T lymphocytes. So T lymphocytes can be further divided to CD4 plus and CD8 plus lymphocytes that have specific proteins on their surface. So the activation of the adaptive immune system requires the contact with the antigen, with the T cells, and also the major histocompatibility complex is uh, required to be present, and the dendritic cells will also have a specific receptors. After the antigen presentation, there is an activation of the T cell. The T cells will replicate. So dendritic cells here will present the antigen, and then after replication, there will be a differentiation, and the T cells will also produce cytokines that activate the other immune cells, including the B cells, T killers, and phagocytes. So these cells are already have antibodies on their surface, so but they are more specific and will identify, kill, and phagocyte the antigen. And to influence this immune system, we need to affect one of the proteins that are responsible for this process. So if we look at the antigen presenting cell, that was a dendritic cell on the previous picture, and this is a T cell. T cell cells will have a CD4 protein on their surfaces. That is the major protein that is interfering with the major histocompatibility complex, and CD3 receptor is required for that, that will further increase the calcium and activate the replication further. Also CD28 and CD28 on the surface of the T cell, and CD80 or CD86 proteins are required as the additional protein. This is not the primary one and this activation will lead to the increase in the calcium, and calcineurin will further lead to phosphorylation of the and fat goes to the nucleus, and that will trigger the interleukin production of the interleukin 2. Interleukin 2 is one of the cytokines that will release from the T cell and then lead to the activation of the other immune responsible cells like macrophages and T killers, and will activate interleukin receptor on the surface of the same cell and also other T cells. Activation leads to the activation of mTOR, of mammalian target of rapamycin, and that will lead to the start of the replication, so the cell will go to the M phase from the G0. So the G0 is a dormant phase when the cell is not replicating, it's not dividing. So that will lead to the increase of the number of T cells and also macrophages, natural killers, and B cells as well. So, and these are the drugs that influence these processes. On every step there is some drug that will uh, inhibit the activation. So, and we start with the uh, antimetabolites. So antimetabolites include azathioprine and mycophenolate mofetil. So some of these antimetabolites are also anti-cancer drugs. We studied last week. And antimetabolites like azathioprine will convert to the 6-mercaptopurine, uh, and they will replace the purines like adenine, guanine, thymine, cytosine, or pyrimidine. So these are actually purines, and that will block the synthesis of the DNA. Uh, then we have the corticosteroids. We also studied them as anti-inflammatory drugs, but they are also have immunosuppressive adverse effect. That is adverse effects, but sometimes it's not adverse effect, it's primary action of them. So we have prednisone, prednisolone, and methylprednisolone that is injectable. This will activate glucocorticoid receptor inside the cell, that is a cytosolic receptor that will transfer to the nucleus and decrease the synthesis of the AP1 and NFKB, nuclear factor kappa beta, and uh, that will further decrease the inflammation because they will suppress the synthesis of the inflammatory substances like interleukin 2, for example. Then we have calcineurin inhibitors. These are tacrolimus, sirolimus, and cyclosporine. So these are inhibiting the calcineurin by binding to the specific receptors, cyclosporine for the cyclosporine receptor and tacrolimus for FK binding protein, and that will decrease the calcineurin phosphorylation and of the fat and cancer. They will decrease calcineurin activity. Then we have anti-thymocytoid globulins that are affecting uh, uh, the thymocytes. So these proteins will decrease the activity of the T cells. And also we have a co-stimulation blockers like abatacept and belatacept. This will block CD28 and CD80 receptors interaction, so they block CD80. This is required for uh, activating of the magic histocompatibility complex. Also we have antibodies for the interleukin 2 receptor, that is basiliximab. This is a monoclonal antibody for the interleukin 2 that prevents the activation of the other thrombocytes. So these are all the drugs, and thank you for your attention, and see you next week.